Tourism is big business. There's almost nowhere on Earth you can't go. But the ultimate destination may be 100 kilometers above your head. Space tourism visionaries are creating the next generation of holidays that are out of this world. The getaway of the future will be a trip to the stars, the opportunity to rocket far from the Earth. The 21st century spaceman could be you. This could be the ride of your life. The Final Frontier offers the greatest adventure holidays. Check into a luxury billion-star space hotel. Catch a game of football in zero gravity.
Come on!
Or treat your partner to a date with a difference by taking them to dinner, trillions of kilometers from home.
The Wright brothers didn't think there'd be hundreds of people having a meal going to London. I think that in my lifetime you will see resort hotels in orbit.
Stardate 2020. Your dream holiday starts here. Just $4 million buys a seat to fly a couple of 100 kilometers into outer space. This is the Galactic Suite Space Resort. Your room is a super deluxe pod with zero gravity as standard. And this room comes with the most incredible of views. The resort orbits the Earth every 80 minutes. It's possible to watch not just one spectacular sunset, but 15 every day. And this isn't science fiction. It's about to become science fact. In the Spanish city of Barcelona, a team of space architects are hard at work designing a space hotel fit for the stars. They're backed by a secret investor with $3 billion of cash to splash. And they're already taking reservations.
Never
before has the space been designed for tourists, where their comfort, needs and activities take on a different level of importance. What's important to us is to be amongst the first that can do it.
At his boutique hotel, Xavier plans a 3-bedroom deluxe suite. The hotel will travel around the globe at 30,000 kilometers an hour, 450 kilometers up. Xavier's even planned a holiday wardrobe for the space tourist. Check in and slip on a Velcro spacesuit. And you can attach yourself to a wall like Spider-Man. 38 wealthy wannabe space tourists have already booked their hotel rooms in outer space, even though the plans are still on the drawing board. But across the Atlantic, one man is betting on making your space vacation dreams come true even sooner. Just a few kilometers from the casinos, billionaire hotelier Robert Bigelow is taking the biggest gamble of his life.
I kept it a secret for a long time,
as to what my real ambitions were, trying to work like a dog and save money and take a lot of risks.
Robert made his fortune in hotels. Now he set his sights a lot higher. But his plans came as a surprise back at home.
When I told my wife that I was going to do something like this, she said, "You're going to do what?"
Robert's idea is out of this world. He's taking real estate into space, developing a giant space station that gives new meaning to high-rise living. He intends it to be used for different purposes, as a home, an office, or a weekend retreat.
What we're out to do is try to create a safe, affordable environment that's larger and larger for people to do all kinds of things.
Okay, I'm in position, Dave.
Building in space is a costly exercise. The International Space Station cost a whopping $100 billion. Robert needed a design that would be far easier to construct and one that wouldn't break the bank to build. NASA came up with a solution. They were developing a huge, lightweight space habitat that inflates in orbit, making it cheap and easy to launch. But when NASA's research costs spiraled, the project was scrapped. Robert saw his chance and snapped up the plans.
These systems are extremely strong. They're not balloons. Best correlation I can give you would be comparing it to the tire on your car. It's made up of multiple layers, steel belts, and other kinds of very strong materials. And that's the same way with our architecture.
But would the idea fly? There was only one way to find out. In 2006, Robert launched a prototype, hitching a ride on a Russian rocket.
In my mind, I thought, there's going to be all kinds of things going wrong. We're going to fail.
To everyone's amazement, not only did the station inflate, but it also managed to broadcast extraordinary live footage back to Earth.
Biggest shock was, oh my God, what we're doing is working for real. It can't get any better than this.
Now Robert is building the real thing, a full-size place in space. The launch party is planned for 2014, and the onboard entertainment promises to be spectacular.
We will also have many cameras on board our spacecraft, and on a large section of wall, see any number of different angles of what's outside, so you could get right up on the moon. Even though you're only in low Earth orbit, you might have the moon right in your face.
With limitless shapes and sizes, inflatable buildings could make almost anything possible in space. Imagine experiencing new sports that can only be played in the zero gravity of space. Join the crowd at the Zero Gravity World Cup in a gigantic orbital space sports stadium.
Come on!
This is the dawn of a new era of space tourism. The sky is no longer the limit. But some have been unable to wait to get their space fix. In 2006, Iranian-American entrepreneur Anousheh Ansari became one of the first space tourists.
I believe that there is something inside us always attracting us to the night skies, maybe because we're made of stardust.
She paid $20 million to take a holiday at the International Space Station and made a video of her adventure.
Just having the opportunity to fly from one end of the station all the way to the other, it was great. And I tried to go really fast and show off that, you know, I'm made to be in space. I'm made to be an astronaut.
Everything on board was pretty relaxed, especially in the dining room.
It's the only place that you're allowed to play with your food. Any simple task that you do on a daily basis, you know, brushing your teeth, drinking water, just eating can be fun.
And in space, there's not much space. But this is a room with a view.
This is my sleeping bag right here, right by the best view from the world. And I can see the clouds, the Earth rotating by. I see the curvature right there. That was actually my favorite time to just, you know, look at the night skies. I felt like, you know, I could live in space forever.
Anusha's trip cost her a cool $2 million a night. But there's good news for the rest of us. In your lifetime, you could be taking your own, more luxurious, affordable space adventure.
10, 9, 8, go for main engine start. 6, 5, 4.
One thing stands between you and the ultimate holiday in space: gravity.
Space Shuttle Atlantis, reaching the crest of its historic...
To overcome it costs a fortune. $500 million per shuttle launch. The rockets use vast amounts of fuel, held in gigantic throwaway tanks. It's clear that for space tourism to take off, some clever thinking was needed. So in 2004, millionaire space enthusiast Anusha Ansari set the world a challenge by funding a $10 million competition to create low-cost spacecraft.
The only thing that can drive innovation is competition, to make access to space faster, safer, easier, and cheaper.
Teams from around the world took up her X Prize challenge. But in Mojave, California, maverick engineer Burt Rutan was ahead of the game. He was already working on a secret spacecraft.
Can you do a dog? A dog? That's
Burt is an aviation legend. You might say he's light years ahead of the competition.
Okay, I'm going to do a lion. Okay, you ready?
He had already built a plane so lightweight, it flew around the globe on a single tank of fuel. And he smashed altitude records with Proteus, which soared to more than 63,000 feet.
Ready to go?
Now, he's set his sights on sending tourists into space.
Listening to those that have been in space, the way they describe it, it seems life-changing to look down on the planet. And a chance to go there and look at that? Wow.
Just 5 months after the X Prize was announced, Burt Rutan rolled out Spaceship One. It had taken more than 3 years to build. To escape Earth's gravity, Burt used an ingenious design, with not one plane, but two. An aircraft would carry the space plane beneath its fuselage and release it at 50,000 feet to rocket into space.
Ready, Matt? 3, 2, 1, release.
Lead release. Arm.
Pilot Brian Binney fired the rocket.
Good flight. Good flight. Copy.
Holy, that was cool.
He narrowly missed a collision with the mothership.
That's good, though.
350, suggest shutdown. Roger, shutdown.
Within seconds, he had crossed the boundary into space, 100 kilometers above Earth.
Well, it's really quiet up here. I'm gonna get the camera out. Roger that.
Binney was able to take a few snaps for the album, from the first privately built spaceship to reach space.
RCSC on. Copy that, Brian. It's moving and it's green. The CTN's a little warm, but looking fine. 3, 2, 1, coming down.
The civilian race for space had been won. But for Bert, this was only the start of his dream.
If I could please invite onto the stage Bert Rutan, the designer of the first private spaceship, Spaceship One. Bert?
I'll tell you something. I have a hell of a lot bigger goal. And you know what that goal is? I absolutely have to develop a manned space tourism system that's at least 100 times safer than anything that's ever flown manned to space, and probably a lot more. I have to do that.
Bert's ambitions are shared by billionaire entrepreneur Sir Richard Branson, and together they have set their sights on helping you reach the stars. Thousands of kilometers away, at his private Caribbean island, Necker, Richard puts his mind to taking tourists into space.
I'm old enough to have seen the moon landing, and I assumed that I one day would go to the moon. But the decades went by, and government-run space agencies were not that interested in getting you or me into space. So, out of frustration, we decided to create a private spaceship company where we could get as many people as possible to be able to experience spaceship travel.
This is Richard's dream, to use Bert Rutan's spaceship technology to take you on the trip of a lifetime. On board a spaceplane, you'll jet 60,000 feet up, to then rocket at 5,000 kilometers an hour, up to outer space. Pop your seatbelt and float in zero gravity. Then, check out the amazing views. You'll coast 104 kilometers above Earth for 6 whole minutes, until it's time to go home.
This spaceship will glide serenely back to Earth, and my guess is that quite a lot of them will be itching to get back up again.
Today, rocketing to space isn't for the faint-hearted. Astronauts must train hard to prepare for launch day. They have to be super fit to handle the extreme force of gravity.
2, 1, 0, booster
off of Discovery.
But Richard Branson's business banks on just about anyone being able to fly, regardless of age or levels of fitness. Something Dave Clark, who must find future passengers, is all too aware of.
What if we had the spaceships and we had all these people signed up and then nobody was actually physically able to fly?
To find out if the average person could jet into space, the NASTAR Center in Philadelphia has developed a custom flight simulation.
We've developed a centrifuge program to replicate as almost exactly what's going to happen to your body in your trip into space.
GX now, concentrate on your breathing.
And finding out how most people would react has never been done before.
The data that they have on centrifuge is mostly from the military. These are the most healthy, perfectly proportioned, physical specimens of the population. These are Top Gun pilots, whereas we have people's kids, people, overweight people, older people.
Now talk about your gene training profiles.
75 space tourists, including Richard, have volunteered to go for a spin. They are about to discover what 5,000 kilometers an hour feels like.
You got the training, you got the tools, you know what to do. All right, go. You're at Mach 2, climbing at 80,000 feet.
The trainers ratchet up the G's. This is as close as it gets to the real thing.
You're feeling the rush in the heart, you're feeling the pressure on your chest.
Coming up to Mach 3.
The adrenaline is flowing.
Here's your chance to catch your breath.
Thank you very much.
Richard, tell us, what was it like?
It was wonderful. I mean, it's so important to go through that so that when you actually go into space, you can just lie back and enjoy the whole experience and not be worried about, is your body going to cope?
Richard sails through the test. But will the oldest volunteer, scientist Professor James Lovelock? He's 91 years old, and he's hoping he too will be able to fly to outer space. Space tourists will feel the power of G-forces. During takeoff and landing, the heart struggles to pump blood to the brain. But with training, it is possible to avoid the dangers. By squeezing your leg muscles, you can improve blood flow, making for safer spaceflight.
Welcome back to Earth, astronaut. You are now our most senior centrifuge rider. You hold the record. Oh, good.
All 75 wannabe space tourists pass with flying colors, proving it is possible to fly into space, whatever your age or condition.
Did well. Did well, James.
The G-forces are quite brief, and the centrifuge has now shown that really anybody can do this flight. Stephen Hawkins is planning to go into space with us. He'll be able to put up with it. James Lovelock, the environmentalist, he's going to go into space with us.
Now, it's just a case of saving up to buy your ticket for $200,000.
We've got to try to come up with, clever ways of getting that price down and down and down. Every $10,000 we can get it down opens the market up that much more. And I think 50 years from now, hopefully literally hundreds of thousands of people will be able to afford to go into space.
Richard Branson had the vision to turn space into the ultimate tourist destination. Now, all he needed was a spaceship. Back in Mojave, following his X-Prize win, Burt Rutan and his team started engineering his space tourist dream.
what we're doing is important because it's doing something that's never been done.
Bert's prize-winning prototype, Spaceship One, carried just one pilot into space. There's not enough room for space tourists, so Bert scales up his spaceship and creates a version for 6 passengers. And it's built with the sightseer in mind. Each passenger gets a window seat next to an aisle. It's double the size of its predecessor, so it needs a bigger, twin fuselage mothership. But safety is always a top priority.
We can't achieve the level of safety that you do with modern airliners because they've had 7 decades of maturity. However, I do feel that to fly the public, this should not be looked at it as a dangerous adventure.
But modern airliners don't have to re-enter our planet's atmosphere. Anything speeding towards Earth tends to burn up. Bert's determined to ensure his space plane will be hundreds of times safer than spaceflight today. So, he has developed a revolutionary way for his spaceship to re-enter the Earth's atmosphere slowly. The space plane's wings pivot 65 degrees. Its fuselage flattens into the airstream, creating stable drag, like a shuttlecock. Spaceship Two is so lightweight and the drag so high, it rapidly slows down without heating up. Then, at 70,000 feet above the ground, the wings realign like a glider, and the craft touches smoothly down on the runway.
My solution was to find the very safest way to land a manned spaceship. To me, it was the simplest way of doing a difficult job.
October 2010. It's taken 5 years to develop Spaceship Two. Today, she's leaving the hangar for her maiden voyage. At Mojave Spaceport, there is only one question on everyone's lips. Will she fly? Richard and Bert have gambled their reputations and a small fortune on the odds that she will. They are about to find out.
Standing next to Bert, watching it get higher and higher and higher. Obviously, Bert was understandably extremely nervous. I was nervous for him and for us.
45,000 feet above their heads, it's the moment of truth.
10 seconds. We are armed. Release, release.
Clear the plane.
Release.
Okay, it's gone. All good, all good. Beautiful, beautiful.
Yeehaw!
That's great. Beautiful flight.
She flies perfectly.
We got word back that it was flying absolutely beautifully. It was a tremendous moment. You know, we really are close to the dream becoming a reality.
Beautiful job, Steve.
The final frontier is one step closer. Soon, you could be taking your seat on this spaceship for your unforgettable 6 minutes in space. But for these stargazers, this is only the beginning. If they have their way, you could travel on their spaceship to an orbiting hotel for the ultimate space vacation.
A lot of my life has been about dreams. If you don't dream, you don't make anything. One day you might see a giant V floating around the Earth.
The Wright brothers didn't think there'd be hundreds of people having a meal going to London. I think that in my lifetime you will see resort hotels in orbit.
Staying at a space hotel, you can expect more than 5-star luxury. From here, you can gaze on an entire galaxy.
I think the important thing about being in a space hotel is that you have massive windows, and so you can look out at the universe around you and marvel at it.
And once you've been there, space travel agents will be booking your trip to the next holiday hotspot. Have you ever gazed up at the moon, tracking across the night sky, and wondered what it might be like to visit, to fly over its craters, or take a walk across the lunar landscape? At 400,000 kilometers from Earth, it would take you days to get here. So once you get here, you're going to want to stay around. In Las Vegas, Robert Bigelow thinks he can offer you the perfect place to stay. His inflatable space station could open as the first moon hotel.
What you have is an entire station that's really a potential lunar base. We would use low Earth orbit as the trial place of assembling these craft. And with a few modifications, we can turn these stations into bases.
Once you land here, Hotel Moon will offer the latest in cosmic comfort. This is one resort where they really will have thought of everything, including the breakfast buffet. In the arid desert near Tucson, Arizona, feeding lunar tourists is food for thought.
We're going to go to the moon, or we're going to go to Mars or beyond, and we have to survive. And unless we're going to carry a picnic basket of fresh vegetables and processed foods, which we can't do in the long term, we're going to have to grow our own.
If you're going to enjoy fine dining on the moon, you'll need a space food expert like Dr. Gene Giacomelli. He knows how to grow crops that are out of this world.
I find this very exciting, to be able to use agricultural technologies to grow plants to feed people like we do on Earth, but to bring that to space.
On Earth, our atmosphere filters out dangerous solar radiation that would otherwise wipe out crops, rainforests, and woodlands. But on the moon, there's no protection. For crops to survive, a greenhouse would have to be shielded. Buried underground to protect it from the sun, it could nurture crops with very little help from people.
The lunar greenhouse, in many ways, is a robot. It automatically provides its climate so that the plants grow in the way we want them to grow. It provides the temperature and the light, carbon dioxide, as well as the hydroponic system for nutrients and water.
Gene and his team have already built a prototype lunar greenhouse.
We're growing tomato, sweet potato, strawberry, and lettuce. And this certainly isn't a full diet, but it does offer the crunchiness of a salad, carbohydrate with sugar, and strawberry as a sweet fruit.
Lunar crops will generate drinking water and convert carbon dioxide into breathable oxygen, giving you not just a taste of home, but keeping you alive in space wherever you go.
The system certainly can be used on Mars and the Moon, but why not beyond? Why not in space stations and intergalactic traveling spaceships providing food and life support for the space travelers?
Getting to Mars on today's rockets depends on planetary alignment. The flight is only possible every 2 years, and the trip takes 7 months. Once there, you wouldn't be able to set off for home until Earth realigns again, 18 months later. So engineers and scientists have been looking for a much faster way to fly. Houston, Texas. Behind these shops, in a seemingly bland warehouse, a multi-million-dollar experiment is underway that could put Mars on your space trip itinerary. Franklin clocked a record-breaking 7 trips on the space shuttle. As the wheels touched down on his final NASA mission in 2002, his need for speed grew. He needed a faster set of wings.
Right off the bat, we know that we need something entirely different, something that would get us to speeds that are maybe 10 times faster than what we could do today.
Scrapping conventional thinking, Franklin throws away the rulebook and works out what the problem with speed boils down to.
The fundamental issue of rocket propulsion is that you want the exhaust to be very hot, and the hotter the better.
So, Franklin cooks up a revolutionary new rocket engine. It's powered by one of the hottest things known to man, plasma, and it's about to be fired up inside this vacuum chamber. The rocket is powered by hydrogen gas, which when heated, turns into pure plasma. Powerful magnets push the plasma through the engine to supercharge the spaceship. Plasma is so powerful, you could jet around 4,000 kilometers in a minute and rocket to Mars at 200,000 kilometers an hour, slashing a 7-month flight to just 39 days, with 2 weeks rest and relaxation when you get there. That's a 100-day return trip compared to 3 years flying today's rocket ships.
All my life, I've dreamed about going to Mars and beyond. Space is like a drug, you know, once you get hooked, you don't want to give it up.
In Los Angeles, science fiction is becoming science fact. NASA scientist Dr. Kevin Grazier advises Hollywood on science fiction. And he thinks what you see on the big screen could be just around the corner.
The days of a few astronauts, cosmonauts, going into space, that's over. In the not-too-distant future, we're going to see you, me, regular people going into space.
Kevin thinks science will let us boldly take a holiday where no man has done so before.
A really far-out propulsion system that NASA has actually looked into is antimatter.
Buckle up for a journey on board your intergalactic space liner powered by antimatter. A look under the bonnet reveals a magnetic chamber that contains antiparticles. They're fed through magnetic rings to collide with their nemesis, matter. In just a nanosecond, billions of explosions create an enormous surge of energy, 10 million times more powerful than today's rockets, with a top speed of just over 1 billion kilometers an hour.
Distances to the planets are puny compared to the distances to the stars and galaxies beyond. If we're going to go to places further than our solar system, we're going to have to speed things up quite a bit. Enter wormholes.
Even flying at light speed to our nearest major galactic neighbor, Andromeda, gives new meaning to long haul. It's a 2.5 million year flight time. So if you're going to cruise beyond the Milky Way, you're going to need a serious shortcut.
The name wormhole comes from an apple. Imagine a worm on the surface of the apple who wants to get to the other side. He can do it one of two ways. He can walk all the way around the outside, or he can chew through the middle. The second is a lot shorter, and that's the basic principle of a wormhole.
If we could bend space-time, we could create a wormhole, a time-saving tunnel that connects two places trillions of kilometers apart. Wormholes might already exist and could become your intergalactic freeways to mind-boggling vacations.
One day you might board your shuttle for Wormhole Express at LAX or Heathrow, take that shuttle to your Starliner, and zap!
Do you fancy a vacation trillions of kilometers from Earth? To holiday in a floating city? To soak up a different sun in a distant galaxy? In the future, we may think nothing of traveling throughout the universe. By having fun in space, tourists could create unimaginable new inventions that would reshape our world. Just as the home computer was initially used for simple gaming, it's now the bedrock of our everyday lives.
The people that will be flying in commercial space flights are allowed to be creative. There's going to be 2 or 3 people that come up with something that's called a breakthrough. And all of a sudden, commercial space travel will look completely justified rather than look at, well, these are just joy rides.
Space tourism could take us all to new places and might ultimately ensure our survival.
Earth is the cradle of humanity, but one shouldn't remain in the cradle forever. Single planet species don't last. Ask a dinosaur.
Pushing out beyond Earth's orbit will truly become a space species.
I cannot envision all of humanity remaining on this planet. Humanity's destiny is in space.
It's not a matter of if the commercial space industry will take off, but when. It was just over 100 years ago that the Wright brothers flew their first airplane, and now we don't think a thing about jumping in an airplane and flying across the continent or across the largest ocean. Today's commercial space pioneers who are just tickling the edge of low Earth orbit are today's Wright brothers.
Watching the night sky when there are no bright lights and the atmosphere is clear can be a fascinating experience. Look at the sky on a dark, clear night. Observe it carefully. You will see the entire sky dotted with countless twinkling objects. These objects are called stars. Some stars are bright and some not so bright. The star-like objects which do not twinkle are planets. The stars, the planets, the moon, and other objects in the sky are called celestial objects. If you observe the moon continuously for several nights, you will notice that there is a visible change in the shape of the moon every day. The day on which the whole disk of the moon is visible is known as the full moon day. Thereafter, every night, the size of the bright part of the moon appears to become thinner and thinner. This phase is called waning. On the 15th day, the moon is no longer visible. This day is known as the new moon day. The next day, only a small, thin portion of the moon appears in the sky. This is known as the crescent moon. Thereafter, every night, the size of the moon grows larger. On the 15th day, once again you will be able to see the full moon. This phase is called waxing phase. The various shapes of the bright part of the moon as seen during the month are called phases of the moon. Mercury has no atmosphere, which means that there is almost no air on Mercury. These factors contribute to the fact that the surface of Mercury has the greatest temperature range of any planet in our solar system. The surface temperature on the side of Mercury that is closest to the Sun reaches 427 degrees Celsius, while on the night side the temperature drops to minus 183 degrees Celsius. Mercury has no natural satellite of its own. Rotating slowly and in the opposite direction as almost all the other planets is Venus. Venus has no natural satellite of its own. It is almost identical in size, gravity and density to the Earth, and it also has an atmosphere. On the surface, Venus has volcanoes, mountains and sand. The temperatures on Venus can reach almost 482 degrees Celsius. Venus is global warming at its worst. The atmosphere contains mostly carbon dioxide, making Venus a highly toxic place. Venus is mostly covered with yellow clouds, which reflect sunlight, making it the brightest planet in the sky. It appears in the eastern sky before sunrise, or sometimes it appears in the western sky just after the sunset. Therefore, it is often called the morning or the evening star, although it is not a star. The Earth is the only planet in the solar system on which life is known to exist. Some special environmental conditions are responsible for the existence and continuation of life on the Earth. These include the right temperature range, the presence of water, suitable atmosphere, and a blanket of ozone, and just the right distance from the Sun. The Earth appears blue-green due to the reflection of light from the water and landmass on its surface. The Earth's axis of rotation is not perpendicular to the plane of its orbit. The Earth is inclined to its orbital plane at an angle of 66.5 degrees. This tilt is responsible for the change of seasons on the Earth. The Earth has only one natural satellite, the Moon. The first planet outside the orbit of the Earth is Mars. Mars appears slightly reddish, and therefore it is also called the Red Planet. Its red color comes from iron oxide or rust in its soil. The surface of Mars is full of dirt with rocks everywhere. Mars has higher mountains and deeper canyons than any other planet. It also has the biggest volcano in the entire solar systems, Olympus Mons. Mars has two small natural satellites, Deimos and Phobos. Jupiter is the largest planet in our solar system. It is so large that about 1,300 Earths can be placed inside it. However, the mass of Jupiter is about 318 times that of our Earth. Jupiter rotates very rapidly on its axis, creating storms in its atmosphere. Most of Jupiter's storms seem to never end. Jupiter's great red spot, visible in the picture above to the right, is where a giant storm has been raging for at least 300 years. Observe 4 of its large natural satellites. Jupiter has 63 confirmed natural satellites, which is the largest number of satellites for any planet in the solar system. It also has 3 faint rings around it. Beyond Jupiter is Saturn, which appears yellowish in color. What make it unique in the solar system are its beautiful rings. There are 7 rings around Saturn. These rings are not solid, but rather are made up of particles of ice, dust, and rocks. Saturn is the least dense among all the planets. If you were to throw Saturn in a huge ocean, Saturn would float on it. Saturn has 62 confirmed natural satellites. Titan is the largest natural satellite of Saturn. It is the only celestial object other than Earth where liquid has been found. Rotating from east to west is Uranus, the 7th planet in the solar system. Uranus is unique in our solar system because it is tilted 98 degrees. Its atmosphere is composed of hydrogen, helium, and methane. The temperature in the upper atmosphere is so cold that the methane condenses and forms a thin cloud layer, which gives the planet its blue-green appearance. Uranus also has rings, but they don't stretch out as far as the rings of Saturn. The rings of Uranus are made up of black dust particles and large rocks. Uranus has 27 confirmed natural satellites. The last planet of the solar system is Neptune. This planet has large dark circles on its surface, which astronomers believe to be storms. Neptune has 2 thick and 2 thin rings which surround it. Neptune also has 13 confirmed natural satellites. In addition to planets and moons, there are other celestial bodies in the solar system, such as meteors and meteorites, comets, and asteroids. There is a large gap between the orbits of Mars and Jupiter. This gap is occupied by a large number of rocks that revolve around the Sun. These materials were never incorporated into a planet because of their proximity to Jupiter's strong gravity. These are called asteroids. Some of them can be very large, while others are as small as a grain of sand. Asteroids are leftover materials from the formation of the solar system. By dating asteroid falling on Earth, we know that the planets were born 4.5 billion years ago. A meteoroid is a piece of stone-like or metal-like debris which travels in outer space. If a meteoroid falls into the Earth's atmosphere, it will begin to heat up due to friction with the atmosphere and start to glow and then disappear. This is called a meteor. Meteors look like bright flashes of light that appear suddenly in the sky. They are also known as shooting stars. Larger meteoroids that do not burn and evaporate completely in the atmosphere and reach the surface of Earth are called the meteorites. Meteorites' strikes on Earth can cause massive damage. Craters are formed on Earth's surface as a result of the impact of the meteorites' strikes. Comets are the most brilliant and most rare objects in the night sky. A comet is made of rock, dust, water ice, and frozen gases. When a comet gets close to the sun, part of the ice starts to melt. Sunlight bounces off the comet's ice particles in the same way light is reflected by a mirror, making them shine brilliantly. The solar winds then push the dust and gas released by the melting ice away from the comet. This forms the comet's tail. So, if a comet is traveling towards the sun, then the tail will follow behind and will become longer. But if the comet is traveling away from the sun, the tail will be in front of the comet and becomes shorter as comet again freezes. Besides the moon, artificial satellites revolve in orbits very close to Earth. Artificial satellites are always launched from Earth. India has also launched various satellites. Some of these artificial satellites are Aryabhat, INSAT, IRS, and Kalpana-1. Artificial satellites are used for various applications like radio and television signal transmission, weather forecasting, remote sensing, and telecommunication.
Hello, I'm Rebecca Barnes, and welcome to the Science at Easter podcast. In this episode, we'll discover the motions of stars, learn how astronomers measure their distances, and look at the new European mission that will really get to grips with our place in the universe. For thousands of years, humankind has relied on the positions of stars in the night sky to develop calendars, to tell the time, and to navigate the seas and oceans. Astrometry, the measurement of the positions and motions of celestial objects, is one of the oldest branches of astronomy. The stars in the night sky appear to be fixed in position and at an equal distance away from us. This is the concept of the celestial sphere, on which stars have been grouped into constellations since ancient times. What is difficult to imagine when looking at the night sky is the immense depth of the sky. We do not get a three-dimensional view.
If the position of a star on the celestial sphere is observed over a period of 1 year, as the Earth orbits the Sun, the closest stars will appear to move against fixed, more distant background stars. This is the parallax. It is the only direct way to measure distances to celestial objects. Astronomers measure the position of a star from 2 points in the Earth's orbit with a known separation. This distance and the measured angular displacement with respect to the fixed background can then be used to calculate the distance to the star. Due to the concept of parallax, a star followed for a year appears to draw out a small circle against the background, which is actually due to the Earth's orbit around the Sun. The further away the star, the smaller the circle. This means that at some distance this circle will appear to be a point, and the parallax would be impossible to measure. For stars which are more than a few thousand light years away from Earth, the parallax angle becomes too small to be measured accurately by ground-based observatories. Therefore, astronomers have developed other indirect methods to find distances to celestial objects that depend heavily on theoretical models and assumptions.
The discipline of precisely measuring the positions of stars has a strong European heritage. Astrometry was pioneered long before the astronomical telescope existed. In ancient Greece, Hipparchus of Nicaea painstakingly made naked eye measurements of the positions of the stars and planets, producing the first catalogue of just over 1,000 stars. Over the centuries, many astronomers, including Tycho Brahe, John Flamsteed, and Otto Struve, continued this task with ever-advancing technology. Accurate measurement of star positions from the surface of the Earth is a difficult task. Positions can only be measured relative to other stars that can be seen, and only within a small portion of the sky. In addition, the Earth's atmosphere distorts the stellar images to some degree, thereby limiting the accuracy with which their location can be defined. The biggest advancement in mapping the stars came late in the 20th century, 40 years after the beginning of the space age. In 1989, Europe launched the first spacecraft to chart the positions of the stars. During a mission lasting just over 3 years, Hipparchus mapped over 100,000 stars with very high accuracy. This provided astronomers with a three-dimensional picture of the distances and movements of stars in the vicinity of the Sun. The wealth of data collected by Hipparchus is still being used by astronomers all over the world, more than 15 years after the satellite ceased to operate. When measuring the positions of stars, a huge amount of information is collected. This information is extremely important in all disciplines of astronomy, such as studies of the solar system, stellar structure and evolution, the Milky Way, cosmology, and even general relativity. Let's have a look at a few examples.
With information collected by the Hipparchus mission, astronomers were able to determine that the Milky Way is changing shape and identified that billions of years ago our galaxy swallowed a small, neighboring galaxy as it passed too close. Amongst other numerous results, data produced by this mission helped astronomers to predict when comet Shoemaker-Levy 9 would collide with Jupiter in 1994, and confirmed Einstein's prediction that gravity bends light. Catalogs of star positions are routinely used to point ground-based telescopes, navigate space missions, and drive planetaria. Information from Hipparchus has enabled astronomers to trace the Sun's passage through the galaxy back in time. This has shown that over the last 500 million years, the Sun has passed through 4 of the Milky Way's spiral arms. The times that these traverses occurred appear to coincide with extended cold periods on Earth. Perhaps the densely filled star and gas environment of the spiral arms have an effect on the Earth's climate. Mapping the positions and motions of stars allows astronomers to develop a frame of reference, which in turn means that comparisons can be made between measurements of the same object taken at different times, at different locations, and in different wavelengths. Astrometry measurements are instrumental for timekeeping. Universal time is calculated by synchronizing atomic time to the Earth's rotation. Measuring star positions allows a frame of reference to be developed, so as more accurate positions can be achieved, a better measure of the Earth's rotation can be determined. In combination with other data, many other physical properties of a star can be determined from astrometric data, such as the luminosity, radius, mass, and age. This information is then used to understand the internal structure and can lead to even deeper explanations of stellar and galactic evolution. Accurate data about the distances of stars, combined with models of stellar evolution, are used to find stars that are like our Sun now. These solar twins are targets in the hunt for exoplanets which may harbor life.
This is just a small taster of the exciting and fundamental science to which astrometry data can be applied. Further examples are tracking near-Earth objects, the discovery of new objects within the solar system, and even the dynamical consequences and distribution of dark matter in our galaxy and the universe. Despite the wealth of data delivered by Hipparchus, fundamental questions about our galaxy remain. In the night sky, the Milky Way can be seen as a band of dust and gas that obscures the view of the galactic center at visible wavelengths. Studies of other galaxies have shown that the structure of the Milky Way should be in the form of a disk, a central bulge, and a halo. astronomers are sure that our galaxy's disk has a spiral shape. But how the arms formed and exactly how many there are remains unclear. To really see the structure of the Milky Way, astronomers need to observe a much larger sample of stars that cover the entire spatial extent of the galaxy. The Hipparchus mission only saw a tiny fraction of stars in the Milky Way and was limited to a region around the solar system, therefore not enough to lead astronomers to conclusive results. More stars at greater distances need to be mapped. ESA is continuing to build upon the European heritage of astrometry and the legacy of Hipparchus with Gaia, a new European mission that is due to launch early in the next decade. Gaia will be able to detect much fainter stars and provide more accurate parallaxes than the Hipparchus mission. Gaia will therefore, over its 5-year lifespan, be able to study 1 billion stars in the Milky Way and beyond, to make the largest and most precise 3-dimensional map of our galaxy.
To make this colossal study, the Gaia spacecraft will have 2 optical telescopes which will focus light onto one enormous focal plane, feeding 3 instruments. The astrometric instrument will detect stars as they cross the field of view, giving astronomers the star position, proper motion, and parallax. The photometric instrument will collect information about the star's color and brightness, and the radio velocity spectrometer will provide astronomers with spectra of the star in order to determine how fast it is moving towards or away from us. To achieve the precise and accurate measurements that will be needed, the Gaia payload must remain mechanically and thermally ultra-stable. This is achieved by using a special ceramic material to construct the payload and by shielding the payload with a large sun shield that will be unfolded after launch.
Gaia will collect an immense amount of data, in the order of a petabyte, that's 1 million gigabytes. This will all need to be stored and processed. To achieve this tremendous task, hundreds of people from many disciplines, including astronomers, software engineers, mathematicians, and computer specialists, spread all over Europe, form the Data Processing and Analysis Consortium. This consortium will work together throughout the lifetime of the mission to process the data and for 3 years afterwards to then unite the data into a single entity, the Gaia Catalogue, which is expected to be finalized around 2020. This is a huge scientific and logistical challenge. The enormous yield of data obtained by Gaia will have a revolutionary impact across astronomy.
As photons of light from celestial objects travel through our solar system, they are deflected by the gravitational influence of the Sun, planets, moons, and minor bodies. This is the general relativistic bending of light. How much photons are deflected depends on how closely they pass an object and the object's mass. Measuring and correcting for this effect is critical when determining accurate positions of stars. Gaia will follow the bending of light through the solar system and therefore directly observe the structure of space-time with unprecedented precision.
Gaia's sensitive instruments have the ability to detect faint and fast-moving objects. This makes it possible to detect and study the properties and motions of hundreds of thousands of asteroids, comets, and other minor bodies in the solar system, including those that pass near to Earth. Gaia will join Herschel and Planck at the second Lagrange point, and from there will be ideally situated to probe the asteroid blind spot between the Sun and Earth. Further from home, Gaia will be able to detect tens of thousands of planets orbiting stars other than the Sun, as well as measure the orbital characteristics of a significant number of known extrasolar planets. Gaia will make accurate direct parallax measurements of indirect distance indicators, such as Cepheid variable stars, This information will have a major impact on knowledge of the distant scale of the universe.
Globular clusters, which are among the oldest objects in the Milky Way and found typically in the halo of our galaxy, will be extensively observed by Gaia. Measurements of their distance will enable astronomers to precisely determine their age and hence refine the lower age limit of the universe. Gaia will make a complete census of 1 billion stars across the entire sky with the same suite of instruments. This doesn't mean that just a large number of stars are surveyed in detail. It means that all different types of stars will be studied, including those that are extremely short-lived or rare, and each star will be seen many times whilst the census is being made.
Another unique feature of Gaia will be the well-defined sampling of tens of millions of variable stars and tens of millions of binary star systems. Above all, Gaia's large survey of the stars will reach out to vast distances across not only the disk of the Milky Way, but also into the halo. For the first time, astronomers will be able to see the actual structure of our galaxy and the distributions of the stars within, from which a three-dimensional map of the Milky Way can be made. With this crucial information about the shape of our galaxy, the precise positions, parallax distances, radial velocities and proper motions of 1 billion stars, Gaia will provide astronomers with enough data to reveal the history of our galaxy. These data will be modelled to trace the paths of the stars back in time to learn more about the formation of the Milky Way, and also to advance time to discover how our galaxy will evolve over hundreds of millions of years in the future. I'm Rebecca Barnes. Thank you for watching the Science at ESA podcast.